Synthetic dyes, part 3. In this part, we will see the relation between chemical structure and color of dye. And this point is Witt's theory. Grabe and Lieberman in 1868 pointed out that unsaturation was important for producing color. And Owen Witt in 1876 in his chromophore oxochrome theory brought forth the importance of unsaturation in the appearance of color. The relationship between color and chemical constitution of the substance has been explained by different theories like Witt's theory, Armstrong's theory, Bayer's theory, Nedski's theory, Watson's theory, valence bond theory or VBT, and molecular orbital theory or MOT. These are the different theories that says something about the relation between color and chemical constitution of this specific dyes. So, Witt's theory is for our syllabus, and this Witt's theory is nothing but chromophore oxochrome theory. There is a relation between color and chemical constitution of compound. According to Witt's theory, a dye is made up of two parts, namely chromophore and oxochrome. So Witt says that dye is the combination of two parts, that is chromophore and oxochrome. So first of all, as we have already seen, chromophore, the color of organic compound is mainly due to the presence of unsaturation, and that unsaturated group, Witt called this group as chromophore, unsaturated group. Dye on reduction becomes colorless, indicate the dye must contain unsaturation. For example, yellow color diazomethane containing unsaturation on reduction becomes colorless due to loss of unsaturation. Some of these important chromophores are that we have already seen: nitro, nitroso, azo, azoxy, carbonyl, iocarbonyl, azomethine, azoamino, paraquinoid, orthoquinoid, ethylenic. These are some of the examples of chromophores. Two types of chromophores are there. First one is independent chromophore. When a single chromophoric group is sufficient to impart the color to the compound, then it is known as independent chromophore. For example, ortho or paraquinoids. These are the independent chromophores. There are some dependent chromophores. When more than one chromophore is required to impart the color, then these are known as dependent chromophores. For example, acetone contain one carbonyl group. This is colorless, while biacetyl containing two carbonyl group, that is yellow. The greater is the number of chromophores in a compound, the greater is the intensity of color. This effect is observed when this effect is observed when chromophoric groups are in conjugation with one another. This is very important. Only addition of chromophore is not sufficient, but those added chromophores must be in conjugation with one another. Then and then only color intensity will increase. Diphenylpolymer polyenes. When n value of n 0, 1 or this n value increases, n is equal to 0, 1 or 2, that is colorless. But when the value of n becomes 3, it becomes pale yellow. And when it increases 4 to 5 to 7 to 11, the color change is as yellow to orange to copper bronze, and finally when n is equal to 11, it becomes violet black. Similarly, there is one example, that is beta carotene. This is yellow or orange yellow colored. Oxochrome, the second part in the dye, that is oxochrome. Due to the presence of certain groups in the chromogen lead to deepening of the color, but they are not chromophores and do not impart color. Such groups are known as oxochrome. That means presence of oxochrome, deepening of the color takes place, but alone this oxochrome cannot impart or cannot give color to the compound. Greek oxine means to increase and chroma means color. So oxochrome, color increasing, color deepening compounds are known as oxochrome. Some of the important oxochromes are amino, methylamino, dimethylamino, hydroxy, carboxylic acid, sulfonic acid, chloro, methyl, methoxy, cyano, acetyl, COCH3. This one is acetyl, and amide, C double bond O NH2. This is amide. These are some of the example of oxochromes. The oxochrome plays two main functions. They increase the intensity of color. This is the first function. And another, they make chromogen dye by fixing it to fabric or material to be dyed either by association or by salt formation. So these two functions are very important with this oxochrome. Azobenzene is colorless, while para-dimethyl aminoazobenzene, this one is yellow dye. For example, the chromogen, this azobenzene colorless, but para-dimethyl amino azobenzene is dye, but yellow due to oxochromic group azobenzene. Para-dimethyl aminoazobenzene, this is yellow colored. Therefore, the color of the organic compound depend on the type and position of the chromophore and oxochrome present in the molecule. Oxochromes are mainly of two types. Bathochromic oxochromes. These are the groups which deepen the color. These groups shift the absorption from lower wavelength to higher wavelength. That is from violet to red. It is also called red shift. Such groups are known as bathochromic groups. The order of deepening the color is from yellow, orange, red, purple, violet to green to black. This is the order. When the hydrogen atom from amino NH2 group are replaced by R, a bathochromic effect is produced. And second type of oxochromes, these are hypsochromic oxochromes. And hypsochromic oxochromes are groups which decrease deepening of color. These groups shift the wavelength from higher to lower wavelength. It is also known as blue shift. which result in fading or lightening of the color. When hydrogen atom or atom from OH or amino NH2 group are replaced by acetyl group, then hypsochromic effect is observed. So these two bathochromic shift, that is red shift, and hypsochromic shift, that is blue shift, occur when we replaced the specific oxochromes, bathochromic oxochromes and hypsochromic oxochromes. Thank you.